So here is another question. So it has been given that a tennis ball is dropped onto the floor from a height of 10 meter. It rebounds to a height of 2.5 meter after striking the ground. If the ball was in contact with the floor for 0.01 second, for that much duration, what is the average acceleration during the contact? Okay, so take acceleration due to gravity here, 10 meter per second square. Okay, this. Now, so there are two parts of this question. First is the journey of the ball from 10 meter above the ground, then up to the point of striking. Then the second part is the rebound, okay, after striking the ground, moving upwards to a height of 2.5 meters. So we'll treat both of them separately. So first, let's say the first part, we have the ground, okay, the ball is at a height of 10 meters, okay. Here it is dropped from rest, okay. There is no mention about the initial velocity of the ball, so we'll take it as 0, okay. It is at a height of 10 meters, okay. It is dropped from there, Here the important thing is that here the acceleration, it is supporting the motion. The acceleration, that is acceleration due to gravity, is downwards. Also the motion of the ball is downwards, so it is supporting. So here acceleration will be taken as positive. The distance or displacement here, S, is equal to 10 meter, okay. And here let us say just before, we take a point just above the ground, even by a small margin, just before striking the ground, let's say this ball acquired a final velocity of v1, okay, v1 meter per second, just before striking the ground, okay. I'm taking now a very small margin, just before striking the ground, just above the ground, the velocity of the ball, final velocity, is v1 meter per second. We want to find that. So here we'll be using the equation of motion, this v square minus u square is equal to 2as. So here final velocity is v1 square, initial velocity is 0, will be 0 square, 2gs, okay. So here g is 10, because we have been asked to take g is equal to 10 meter per second square, plus g, so plus 10, and s is also equal to 10 meter, okay. So we are taking that. That implies v1 square is equal to how much? 200. That implies v1 is equal to root over of 200, okay. We'll take that. Just before contact, the velocity just before contact, okay, this. Then let us go to the second journey of the ball after striking. So let us say this is before striking or before contact, and now we will go to after contact, the after contact journey of the ball. So it has been given that after striking the ground, okay, after striking the ground, the ball rebounded and moved upwards to a height of the 2.5 meter, 2.5 meters, and then it came to rest. So here the important thing to note, this is the journey of the ball upwards. This is very important. Then the final velocity of the ball is 0 meters per second because it came to rest after moving upwards to a height of 2.5 meter. This is the displacement or the distance covered, and here acceleration due to gravity is acting downwards, motion of the ball is upwards. So here acceleration is opposing the motion, so here acceleration will be taken as negative. I've already explained motion of an object under the influence of gravity, when acceleration will be positive and will be negative, so please check that video. Now here let us take another situation just after striking the ground, just after the contact, a few inches or in whatever distance it is above the ground. Let's say just after striking the ground, let's say the velocity of the ball was how much? The initial velocity of the ball, let's say it was v2 meter per second. Okay, it is just after striking. Okay, velocity just after striking or just after contact. Here it is just before contact. Here it is velocity just before contact, a very small margin before contact. This is v1, this is here v2. So here again we'll be applying the same equation, v square minus u square is equal to 2as. Here final velocity is 0 square, initial velocity, which is the velocity of the ball just after striking the ground, just after contact, which is v2 square, that is equal to 2 into a is equal to minus g, which is equal to minus 10 meter per second square, so minus 10, s is equal to 2.5. That implies minus v2 square is equal to minus 50. Minus minus cancel, v2 is equal to root over of 50, magnitude wise, okay, root over of 50. This is the velocity just after contact, just after contact, because the whole question is revolving around the acceleration before and after contact. Now coming back to the main point of the question, what is the average acceleration during contact. Okay, so here we have two situations. First, just before contact, the velocity of the ball v1, it is how much? Root over of 200. It will be taken as negative because here it is moving downwards, so it will be v1 will be equal to negative minus v1. Then we have another situation, this is before contact. Then we have another situation where just after contact, when the ball was in its upward journey, just after contact, the initial velocity, which was we calculated root over of 50. It will be taken as positive, which is because it is moving upwards. Okay, because we are talking about acceleration here, we have to bring these things. So here it is minus v2. Now we know acceleration is equal to change in velocity by time taken. So here acceleration during contact, here if we add here during contact, that is just before and after striking the ground, between that time interval, change in velocity during contact, time taken for contact. So this we know it is 0.01 seconds. This is change in velocity, that is final velocity minus initial velocity. The final velocity, it is positive, okay, it is positive. By mistake I have taken here plus minus, so it is plus v2, okay, because it is moving upwards. v2 is moving upwards, that's why it is plus positive. v1 is during the downward journey, that's why it is taken as negative. Okay, again I am making it clear, v1 is during the downward journey before contact, that's why it is taken as negative. v2 is the initial velocity just after contact while the ball was rebounding, moving upwards, that's why it is positive, plus v2. So it is final velocity, which is the velocity after contact, that is plus v2, minus initial velocity, which is the velocity just before striking the ground, just before contact, which is minus v1 divided by 0.01 seconds, which is the time during contact. That is equal to plus v2, which is root over of 50 minus root over of 200 by 0.01 seconds. That is equal to root over of 50 minus plus root over of 200 divided by 0.01 seconds. That is equal to, if we calculate, it is coming around 2121.3 meters per second square. Okay, we can write it 2121 meters per second square, which is the acceleration during contact. This, the average acceleration during contact. Okay, this. Okay, so the whole point of this question was to divide it into two parts, before and after contact. The ball was released from rest. So here the important thing to realize is to figure out just before striking the ground what would be its initial velocity. Just before, very small margin, we took that, we determined it. Then after contact, just after striking the ground, a few inches above the ground, just a very small margin of distance, what is the velocity just after, which is the initial velocity, it is taken as that. Then it moved to a certain height and came to rest. So we used again the same equation to determine that, the velocity just after contact and the velocity just before contact. Then assigning the sign. Before contact, ball is moving downwards, velocity is taken as negative. After contact, ball is moving upwards, so positive sign. Then basic formula of acceleration, time of contact, final velocity, initial velocity, and we got the result. Okay, so this is the solution.